Good evening, student. Today I am discussing matrices and determinant not only for class 10 ICC examinations. This could be followed by ISC as well as CBSE 10, 12 as well as for the graduation level also. Because when you go for the matrices of high levels for learning as well as determinants learning, so it's covered the syllabus of not only 10, 12 as well as graduation level. What is matrices I have already defined. Let today put this into more mathematical form. Now matrices, I will say the number of element ij. That means, and this could be written as this way, or aij. This could be written up there. What is I? I is equal to 1, 2, 3. It will assume up to n number of times. Okay. And j is equal to 1, 2, 3, dot 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 up to n number of. That means the I will be up to n. So it is having n row. And we write m. And j is equal to 1, 2, 3, 4 dot 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 n means nth column. So here ij means the element represented by ith column and ith row, jth column, and I is equal to up to n, and jth column is up to n. So order of the matrix is becoming n cross n. Now, dear bird, in case of determinants, it should be like square matrix only. If I write aij, it should be like m cross n. That means I is equal to m, j also 1 to 3 dot dot n. But simultaneously I becoming 2 or j becoming 3, 5, 7 or n. It should be like that. And we do not enclose instead. It is like this. This is we represent the determinant A. Here I say A matrix. Also it could be this way, A matrix. But here determinant is this. Now, if I say this is the square matrix, so with n column and n row only, let us take I is equal to 1, 2, 3, and j also is equal to 1, 2, 3. So here determinant A becoming A1, 1, that is first row, first column, A1, 2, that is first row, second column, A1, 3, first row, third column, then A2, 1, second row, first column, second row, second column, second row, third column. So here is third row, this is third row and first column. So here is third row, second column, third row, third column. So it is becoming order 3 cross 3. That means instead of determinant, if we have written as like matrix, only A say, we don't need to write, this is not determinant matrix, so it should have been like this, that is within bracket. A1, 1, A1, 2, A1, 3, here A2, 1, A2, 2, A2, 3, here A3, 1, A3, 2, here A3, 3. Now, today we will be learning the determinant, how we derive the determinant, as well as we will be learning the matrix multiplications, as well as we will learn how to find out the inverse of matrix. Now, how do I define inverse of matrix A? Now, part to that, I'll say a diagonal matrix. Diagonal matrix means it should be a square matrix, and diagonal elements are unity. Here other elements are 0. This is called diagonal matrix. That is all diagonal. Items are unity, and this is diagonal matrix or the unit matrix. Now, if we represent by A, now inverse of a matrix A is B such that when you multiply these two, we have unit matrix. Either matrix A is multiplied with B or B is multiplied with A. We have unit matrix of the same order. I am assuming A and B are the 3 cross 3 order. When you multiply, so in this case B is equal to nothing, it is A inverse, and we write this way. Now, I will try to find out A inverse, that is the B. And then when you multiply, we get the unit matrix, that is this matrix. Now, expansion of determinant, let us discuss. Now, how do we expand this determinant? Sorry. We have to, if we expand this, first we will write A11, and that will be multiplied with the cofactor determinant. Cofactor determinant means this determinant, with this I want to expand, so this row and this column we omit. So the smaller, that is 3 cross 3, so we have 2 cross 2 determinant. That determinant we will be writing like A22, A23 and A32 and A33. Now, next item is this. Here I have to understand this will be negative. How it is negative? Minus 1 to the power row plus column. Now row is, that is 1 plus 2. 1 plus 2 is 3, which becoming minus. Here 1 plus 3 is 4, so plus. Here 2 plus 1 is odd number, so it should be minus. Here even number plus, here minus, here even number, so plus, here minus, here. So we have, like here for this expansion we have minus. Now we omit this, so 2 1 3 1, sorry, A21, A21, so A21, A31, we are omitting this, so cofactor determinant is A23, A33. And here it is plus only. Now cofactor determinant is A13, that is first row third element. So first row and third column is removed. So we have 2 1 2 2 3 1 3 2. A21 2 2, that is this 2 as well as 3 1, A31 and A32. Now the question is that expanding this A11, then within bracket these two are multiplied. So A22, A33 minus this. So it is coming like this, then minus this. Coming like this, then minus this. Always this. So 8, this minus 3 2 minus 8 2 3 3 2 8 3 2. Now negative minus a1 2 is there, minus a1 2 as well as plus a1 3 is there. So then minus from here I will start doing a11 into a22 a33 minus a23 a32, then we have minus of a2, this is a2 minus a2, a12 minus a12 minus a12, and then we have a21 a33 minus a23 and a31, and plus of a13 a21 minus a21 a32 minus of a31 a22. We have to understand this. After that we will be multiplying this a1 1 with this 2 as well as this 2, this 2, this 2, these 2, this 2, and these all are the real number. So we can simplify and we get the resultant as some real number. So that is determinant A. So let us take one example of matrix of order 3 cross 3 and we will try to find out the determinant A. Let's take. Now I define like matrix A is equal to say 3 minus 2 4 1 6 and minus 2 and say 3 1 2. This is 3 cross 3 determinant. This is 3 cross 3 matrices. Now I have to find out the determinant of this matrix. So I write determinant A is equal to 3 into this cofactor matrix, this into this minus this into this is 12 minus of minus 2, that is plus 2. Then for this minus of minus 2 and we have to remove this 2, so this minus this, that is within bracket 2 into 1 2 minus of 6. So 2 minus of minus 6, that is plus 6. Now with 4, that is a13, that is plus 4 into, we are removing this, we are taking this cofactor, that is 1 into 1 minus this, because always this minus this, 1 into 1 minus 1 minus 18. Now this will become a real number. Let us see, this is 40 minus of minus plus 2, here is 8, here is plus 4 into minus 17. Now 3 into 14 is 42. This is your 16 and this is minus 4 into 17, that is 34 into 2 is 68. Now this is 8, this is 5, minus 68 is equal to minus 10, and that should be not equal to 0 if I want to find out the A inverse. If it's become 0, then A inverse does not exist, because A inverse is equal to, we have to divide by determinant A, determinant of this matrix, and here we find out adjoint of A. Now, what is the adjoint of A? That I will be explaining now, and then I will find out the adjoint of A, and then we will find out the matrix A inverse, and then we can multiply A into A inverse, and then we find out like A into A inverse is unit matrix of order 3 cross 3. Now let us find out. This is minus 10, we have to determine, because we have found out determinant of A is equal to minus 10, that is not equal to 0. Hence A inverse exists. Now I have to find out the A inverse. I have to find out first adjuvant of A. Now what is adjuvant of A? Adjuvant of A is a determinant which is found by taking transpose of matrices which is formed by taking the cofactor. Now cofactor of this element, cofactor becoming this is 12 minus of minus plus 2, that is 14. Now this element is minus 2 we have, and then this is minus 2, and then we remove this, then this into this, 2 minus of minus 6, that is 8. This is once more 2 minus of minus 6, that is 2 plus 6, that is 8. It is becoming minus 8. Now for this element, cofactor is this 1 into 1, 1 minus 18, that is minus 17. But here plus sign, so minus 17 only. Now here we have to remove this as well as this. So we have this. So here Aij, which becomes like second column, first row, so it is negative. So it is negative, and then this into this minus 4, 4 into 1 minus 4, so minus 4 minus 8. So minus 8 within bracket. Here this is minus of this. Now here it is positive because second column, so 2 plus 2 4. Now here is 3 4, that is 3 into 6 minus 12, that is minus 6. So it is minus 6 only. Now here our cofactor is becoming, this is, now let us remove this, so it will be easier. For this, our cofactor is this, that is determinant with this for 3 minus 6, minus of minus 6 plus 6, 9. Plus sign 9. Here for this we have to remove this too. So this that is minus plus 4 minus 24, that is minus 20. Now here for this we have to remove this. This is obviously letting minus sign. So this remove, minus 6 minus 4, that is minus 10. So minus of minus 10 is plus 10. Now here positive again because it is third row and third column, 3 plus 3 6. So 18 minus of minus 2, that is 20 only. Now this is our the cofactor. Now with cofactor we have found like all small determinant, and this is the value. Now transpose means we change row into column and column into rows. So we have very quickly Here I put here, so 14 minus 8 minus 17. So this into this. So next this should be like minus of minus 8, then minus 6, then it should be 9, it should be like minus 20, 10 and 20. So this is your adjuvant A, because we are changing rows into column, rows into second column and third row into third column. So this is adjuvant. Now this adjuvant of a matrix A, matrix A, matrix A, adjuvant of matrix A, adjuvant of matrix A. So we have determinant is minus 10. So we can say A inverse is equal to 1 by, this is came to minus 10, so minus 10, and then you have this element, that is 14, 8 minus 20 minus 8 minus 6, 10 minus 17 and this 20. Now I have explained last day the matrix multiplied with a scalar. This is the scalar. So all the elements should become accordingly. Now we can find out, because of less space I have to remove this. Now A inverse is coming as a matrix minus 14 by 10, that is minus 7 by 5. Then each element to be multiplied. So minus 8 by 10, that is minus 4 by 5. So minus 20 by 10, that is 2 only. Minus 8 by minus 10, that is 4 by 5 only. So minus 6 by this, so it is 3 by 5. 10 by 10, that is minus 1. Minus minus plus, so 17 by 10, and then minus 9 by 10, then 20 by this become minus 2. So this is nothing, A inverse only. Now this is A, and if this is A inverse, then accordingly A into A inverse should be identity unit matrix only, that is of the order 3 cross 3. Now I can write like 3 minus 2 4 and 1 6 minus 2 3 1 2, and then I write A inverse, that is this one only, that is minus 7 by 5, minus 4 5, then 2, then 4 by 5th, and then we have the 3 by 5th, then minus 1, and then 17 by 10 minus 9 by 10 and minus 2. So we have A inverse, this is. So we can find out this two multiplication very easily. Now matrix multiplication is possible when first matrix column should be equal to the second matrix row. Here this is 3 cross 3, 3 cross 3. So multiplication is possible. Now first element of the resultant matrix should be this into this plus this into this plus this into this. Now this into this becoming minus 21 by 5. Now this into this is becoming also minus 8 by 5. This into this is becoming plus 17 by 17 into 4 by 10, that is 17 into 2 by this. This is the first element. So 5 is taken LCM. So 21 and 8 is, it is 21 and 8 is minus 29, and this is plus 34 by 5 is equal to 5 by 5, which is 1. Here it should come as 1. So simplifying this is nothing, it is 1. So I can write like it is coming as 1. Here we will get also 1 1 and remaining we will get the 0. Then it is correctly found, which is nothing by I. Because I have to prove A into A inverse is I matrix. Result should be this. Now second element, that is here, this is the first element, first element. First to second element, with row we will use, but with second color. So minus 4 into 3 minus 12 by 5. This is minus 12 by 5. Now minus 3 by minus 6 by 5 and 4 into this, that is minus, this is minus 9 by this is this into this minus this this into this, that is minus 12 by 5, this into this, that is minus 6 by 5, and this into this, that is minus 9 by 5. 9 into 2 by 5. So 9 into 2 by 5, there is a sign mistake, I think. This into this, this into this, this into this. Transpose we took. Okay. 2 minus 4, 6, 1 minus 2, 3, 1, 2. So here would have been like plus, and so minus 18 by this, it should be 0. So we will get 0. Let us check for the third element. Let us check for the third element. This into, this and this. This and this. 3 into 2, 6. Third element I am checking. This element I am doing it here. 3 into 2, 6 plus 6 minus plus 2. Here is minus 8. Yes, it is becoming 0. So it should be again 0. Similarly, we will get here 0, 1, 0 and 0, 0, 1. Then this is correctly found. So, dear student, I will be discussing more multiplication, matrix multiplication I have not defined earlier. I will be discussing more of determinant and matrices sum, and I will explain the symmetric, asymmetric matrix as well as determinant, various sum and the determinants, so that you become more acquaintance. Okay, good night student. I hope you will sleep well and try a little bit harder to learn more. I will try to help myself. Good night.